Hi, I'm Sarah. I'm from UC Berkeley. I'm a fourth-year PhD student there, advised by Celeste Kidd. And today, my talk is titled Focused or Overstimulated? Children with greater physical and visual engagement do not learn more. So to jump right in, developmental psychologists can probably all agree that there are many different factors that contribute to whether or not a child is attending to something in any given moment. For example, here are two factors that pull children's attention. The first is informational utility. Children look at things that are more useful for learning, which our lab has demonstrated with infant work. But also you can think of things like Maria Montessori's concept of readiness or Vygotsky's zone of proximal development. But attention does not only reflect learning value. Visual salience also pulls attention. Visual salience caused by perceptual features like motion onset, high visual contrast, and hue saturation, for example, contribute. We all live in an attention economy, meaning there is intense competition to keep eyes on screens to maximize ad revenue. This has resulted in many content creators using bright and shiny material to attract and keep children's attention. A growing trend in children's media conflates this type of visual engagement with learning. But it can't be assumed that leveraging visual salience to capture children's attention will necessarily increase their learning. In our work, we are empirically testing this assumption. I'm going to discuss the three most important things that we found. And first off, we have found that visually salient content can disrupt learning despite capturing more attention. We recently published this in the 2024 Proceedings of the Cognitive Science Society. So our experiment gave kids the opportunity to learn some new words. We tested kids ages 3 to 6 years old in an eye tracking task. Each kid was in only one of two conditions, either complex or simple. Kids were presented with a picture of a toy and its name, either with colorful naturalistic scenes in the background, as you're seeing in the complex condition, or a plain gray background in the simple. Besides the videos that you see playing in the complex condition, everything else is exactly the same. These learning trials, as I'll refer to them, were followed by test trials where kids were asked to identify each toy by name. And here's an example of a participant completing those test trials in the lab. You can't hear the audio, but I ask if the child can please hand me the DAX. And when he selects the toy that he thinks is the DAX, we offer no feedback and simply return the toy to the table, shuffle them around so they can't keep track of which ones they've already selected, and proceed to ask for the next one. All right, and here are some of the results. On the x-axis, you are seeing the looking time to the screen as a proportion of trial time, and on the y-axis is the number selected correct out of 6. Within just the complex condition alone, which you're seeing here in red, kids who were paying the most attention to the screen during those learning trials actually learned the least names of the toys. And this was not just a result of better focus among the children who learned the most toy names. This effect is still significant when controlling for focus to the toy in the middle of the screen. So this pattern suggests that attentional capture due to visual salience disrupts learning. Our current working hypothesis is that this is likely due to overstimulation, which has been shown to disrupt processing and lead to developmental learning delays. So this brings me to the second thing that we found, which was that children may appear more engaged when watching this visually salient content. This work is led by Maria Castañeda, an honors student at the Kid Lab in UC Berkeley. She had 2 naive coders rate how much participants fidgeted while watching either those fun, engaging videos during the complex condition or the plain gray background. What these plots are showing is that children watching the visually complex videos were less fidgety than those watching the simple ones, meaning they may have appeared more engaged with the content to anyone who thinks stillness indicates focus. And Maria will be presenting a digital poster on her work tomorrow, so everyone should definitely go check it out. And this brings me to my third and final point, that low-income children see more visually salient content. This means that they are disproportionately impacted by the disruptions to learning that this content could cause. Children's media consumption varies significantly by income, parent education, race, and more. Lower income kids consume a lot more media than some of their peers. Trends show that this gap in screen use is growing. The most recent data available shows that post-pandemic screen times have remained elevated, with the largest increases being observed specifically in children's screen time. Given these trends, we wanted to test whether these types of screen content are also differing among these groups of kids. So we empirically tested whether visual salience varied across the different types of content that these kids are consuming. To do this, we have developed different ways to quantify visual salience, starting with a feature called flicker. So flicker is a measure of changes in luminance. It's linked to a reduction in children's executive functioning immediately after viewing, and it's highly visually salient. Flicker is the single most strongest predictor of gaze location in popular models of visual salience, like the ones cited here. This work is done with my lab mate and collaborator, Alex Yang, who is also here. We developed a computer vision model using OpenCV and Python to measure flicker in children's media, specifically the kinds consumed by poorer kids and wealthier kids. We followed standard measurements of flicker in the visual salience modeling literature, just like the work done by Essex and her colleagues demonstrating that flicker specifically predicts problematically fast pace in children's TV. We calculated the absolute difference in luminance between adjacent frames, giving us our final measure, which is mean flicker, or the average total luminance differences across all frames in each video. We measured flicker both in ad-supported children's YouTube content, which is freely available, and also for pay children's media from streaming services like Netflix, Disney Plus, and Amazon Prime. We've also tested US public television that is crafted to be educational. This includes TV shows like Sesame Street. So here is an intuitive demonstration of flicker. Bluey is on the left and has very low flicker compared to a popular kids YouTube channel, Vlad and Nikki, which is on the right. The plots below are showing the mean flicker for each corresponding video. On the x-axis is the frame number, or time in the video, and on the y-axis is the absolute difference in luminance between adjacent frames. This plot shows a much higher average rate in the free content that is more often shown to poor kids and in higher quantities. Flicker is far lower for paid and educational content from PBS. This is important because it means that we should expect low-income kids to experience greater disruptions to their learning from these materials. They're seeing more visually salient, bright and shiny content more often. So we know that this visually salient content has short-term detrimental effects, including disrupted learning and reduced executive functioning. This type of content is also linked to disordered attention, developmental delays, and other concerning long-term impacts on cognitive and behavioral development, likely because it's overstimulating. Furthermore, young children from low-income families are watching about 4 hours of this content daily, approximately double what their peers from higher income families, at least in the US, are consuming. And that's without considering that these high income peers are probably watching less visually salient content. children are likely to become habituated to this visually salient content with regular consumption, which could make it more difficult for them to engage with educational material and ultimately even disprepare them for school. These higher levels of visual salience in freely available children's media on YouTube, for example, compared to commercial content, means that children from lower income homes are more at risk because of the cost barrier to this higher quality content. So to conclude, I would like to just reiterate my three main findings: that visually salient content can disrupt learning despite capturing more attention, and this is likely due to overstimulation. Children appear more engaged when watching this visually salient content, and this is counter to what many people expect, making it difficult for caregivers and educators to tell when a child is meaningfully engaged or not. And finally, low-income children see more of this visually salient content. Thus, these kids are disproportionately impacted by the potential harms of this content. And so I'd just like to thank my collaborators and you all for your valuable attention. Thank you.
Thank you, Sarah. It's time for questions. So we have a lot of questions.
Is this on now? So thank you very much for your talk. I was wondering if you expect the same results if you look at picture books, because some are very busy and others are more simple. Would you expect to have the same effect on their learning and exploration?
Yeah, I think probably some of the mechanisms would be similar with analog content, although the effects might not be as strong. I'm less familiar with this research, but I know there is some research in curriculum, and especially on multimedia curriculum, looking at that like added salience or color is really helpful for learning when it's used appropriately to point out like what's most important to pay attention to, which I assume a lot of super fun and bright children's books would maybe be more thoughtfully planned in terms of where salience is added.
Just a quick clarification question. Maybe you said this already, but did the children get told that they were to learn the names of these figurines? And did you at any point measure sort of their ability to pay attention to what was going on within the video themselves?
Yeah, so children were just told that we were going to watch a video and to watch it like they would at home, so they weren't told that it was a learning task. And we haven't done any analysis on if they learned anything from the videos. I imagine they probably learned something about the videos as well as the names of the toys, but we didn't have a task that necessarily captured that.
Yeah, it's kind of related to the previous question. I'm wondering, because for me the complex stimulus was kind of distracting. What if, when you are talking about saliency, the agent there were more colorful and salient compared to the, the learning element itself not being so confusing, the background? What would be your expectation in that situation?
Yeah, that's a really great question. So with the complex condition, we chose videos that were all like ambient scenes of colors changing or multiple dogs running around, things like that. So there shouldn't have been a confusing specific referent besides the toy that was in the middle. And we also exposed kids to each toy twice. And in the complex condition, it had a different video background each time. So in theory, they really should have learned the name of the toy and something about the videos, which also, to go a bit further, just a conjecture, the videos that we were showing kids were a lot less stimulating and had like much lower levels of flicker than most of the content that kids are watching. So I would expect that even if they had been slightly distracted, if they weren't doing well in our task, they probably aren't able to learn much from the media that they're really engaging with regularly.
Great, that was an amazing talk. I really liked it. The first study that you talked about where accuracy levels were related to the distractingness of the background, do you know about the media exposure of those kids? Like, can you control for that? What I'm wondering is whether or not if kids have what's the nature of the sample? Like, if the kids already have a lot of exposure to that, do we know that their accuracy levels are decreasing by that level of distraction?
That's also a really good question. So we don't have specific measures of how much these kids were watching TV. These are all kids from Berkeley, California, whose parents tend to be less into screen time, I would say. And just anecdotally, quite a lot of parents were like, oh, my kid's so excited for this study because they get to watch your screen and they never get screen time. So in that way, we might have a few more kids than you'd expect who don't have a lot of exposure to screen time. But I think that would be super interesting to look into further.
Thank you for this talk. I think you're doing really, really important work here. I'm sorry if I missed this, but looking at your graphs, did you actually find a group difference in learning between the, in experiment 1, in the kids who had I know you have the correlation for the attention, but it actually didn't look like they learned less overall as a group. And I'm curious about that, and I'm also curious about whether or not, just to play devil's advocate here for a moment, if those children are more willing to watch those videos longer, then maybe there's a long-term positive impact of having more attention-grabbing things, because if there's not a massive learning difference and they're willing to engage longer with those videos, maybe it's sort of exactly the opposite of your hypothesis. So what are your thoughts on those two things?
Yeah, so first, great point. The means between those two conditions are not significantly different. Kids in the simple condition did slightly better, but yeah, I can't make a strong claim that it necessarily caused a strong difference in learning between those groups. And I really like your second point. I think it's a hard balance probably to strike that, you know, you need content that kids want to engage with, right? We would be smart to implement some of this in educational materials like PBS. For example, if you look at the history of Sesame Street, it's getting higher and higher levels of flicker or visual salience over time. So it's keeping up sort of with like YouTube and the other stuff that kids are watching, which I think is really interesting. And I don't know what the sweet spot might be for kind of overstimulating and having kids on their iPads, like watching something for hours and hours, but not really retaining much because they're overstimulated versus having really boring black and white stuff that like no kid wants to watch. So I think that's a great question, and I would love to keep thinking about that too.
Thanks a lot. Really, really interesting and useful research. I have two questions. One is a curiosity, and the other is a real question. The curiosity is the following. When we teach language acquisition to kids, we start by saying all the things that we do in laboratories, they're not how kids learn. Kids learn because, and then we generally present a picture that you also find very often in the psycholinguistic handbooks on development. You know, there is this very simplified situation in the laboratory where you have two objects, one to the right and one to the left, and they just teach. And then this, as it were, blooming, buzzing confusion, if I may, of what really kids see when they are actually in a learning environment. And I wonder what the moral is with respect to your research, because after all, what I would say is that the actual situation of, I think I stand to the point, the actual situation of learning for kids normally is really very messy and very full of salient. So that's the thing. What's the relation between what you show, to what extent what you're showing is a distortion of the fact that these kids see things 4 hours per day, as opposed to something that should lead to prediction in the actual learning curve in normal kids. That's, normally exposed kids in normal environments. And that the real question is the following. It is known that, for example, exposure to sounds and so on, even very early, gives really neurological troubles. And I wonder whether you have any kind of measure, which is a biological measure, of what could, or what the impact on this kind of exposure could have on these kids. Or if you're thinking about getting them.
Yeah, that's a great point. In terms of other measures, we are definitely interested in exploring like some measure of arousal while kids are watching this content, which is hard to do with kids, but I would love to hear everyone's ideas if they have any. We've thought about doing something like heart rate or pupil dilation, which is tricky when you're showing videos and different kinds of content that would impact that anyway. But I definitely think that would help us further understand what's going on here.
Okay, let's thank Sarah again for her talk.